Section 1. The Great SUV Debate. Myth versus Reality. There is a statement you might hear. It suggests that the large, silent electric SUVs gliding through our cities are a grand deception. The myth is that when you account for their creation and the power they consume, these vehicles are actually worse for our planet than the gasoline-powered SUVs they aim to replace. This idea is powerful because it contains elements of truth. It makes the claim easy to believe. It speaks to our suspicion that simple solutions to complex problems are often too good to be true. The vision of a heavy, battery-laden vehicle being a clean alternative can seem paradoxical. Many dismiss it as environmental theater. However, the fact is far more nuanced, and for many people, ultimately more hopeful. For most drivers in most parts of the world, an electric SUV will produce fewer emissions over its full lifespan than a comparable gasoline model. The journey to that conclusion is not straight. It is a story of trade-offs and an initial environmental cost paid for a longer-term benefit. To understand the true impact, we must look beyond a single moment in the vehicle's life. Section 2. The Cradle of Carbon, Manufacturing Costs and Emissions. The life of any vehicle begins with an environmental cost. This is a crucial starting point in our comparison. The process of manufacturing a car is an energy-intensive endeavor. Factories hum with machinery. Furnaces melt metals. A global supply chain moves heavy components across oceans and continents. All of this consumes vast amounts of energy and produces greenhouse gases. For electric SUVs, this initial carbon footprint from production is typically larger than that of gasoline counterparts. The primary reason is the high-voltage battery. Let us consider a clear example to understand the scale. Imagine a popular, medium-sized electric SUV with a battery pack around 75 kilowatt-hours. That is a measure of the energy it can store. Battery creation is a complex, multi-stage process. Mining, refining materials, energy-intensive cell manufacturing. Producing this battery can generate 6 to 10 tons of CO2. Section 3. Powering the drive. Comparing running costs and energy sources. Once a vehicle leaves the factory, its primary impact shifts from creation to its consumption of energy. This is where the electric SUV diverges dramatically from its gasoline cousin for cost and for emissions. First, the driver's wallet. A typical gasoline SUV might consume around 11 liters per 100 kilometers. At $1.20 per liter, that is roughly $13.20 per 100 kilometers. A comparable electric SUV may use about 22 kilowatt hours, and at 15 cents per kilowatt hour, that is about $3.30. Over a year, the savings add up to thousands, making the EV cheaper to run. Emissions. A gasoline SUV always produces them from its tailpipe, about 2.3 kilograms of CO2 per liter burned. An EV has no tailpipe. Its emissions depend on how its electricity was generated. On clean grids dominated by wind, solar, and hydro, driving emissions are very close to zero. The advantage is immense. On coal-heavy grids, the picture worsens, yet large plants are often more efficient than millions of engines. Consequently, even on a coal-reliant grid, an EV SUV often still has lower emissions per mile. The break-even is simply pushed further out. The margin is smaller, but in most cases it remains. The break-even point moves to a later date. Section 4. The heart of the machine. Battery life, replacement, and recycling. The battery defines the electric vehicle. It is the source of its power, cost, and weight. And many questions. How long will it last, and what happens when it degrades? Modern batteries are engineered for durability, designed for thousands of cycles over many years. Most manufacturers offer substantial warranties, typically guaranteeing around 70% capacity for 8 years or 160,000 kilometers. Degradation reduces maximum range gradually, yet at 80%, the vehicle remains highly functional. For daily trips, that range is often more than sufficient. Many used EV buyers find slightly degraded vehicles still meet needs at lower prices. Replacement packs can be expensive today, a legitimate long-term concern. But prices have fallen dramatically and are projected to keep dropping as scale and new tech arrive. Often, only failed modules need replacement at much lower cost. End of vehicle life is not end of battery life. Second life stationary uses emerge in homes to store solar and in commercial sites to manage loads. Recycling is maturing, improving recovery of lithium, cobalt, and nickel, closing the loop and reducing new mining. This helps shrink future battery footprints. The conversation must include the raw materials that power batteries. These cells are marvels of modern chemistry that rely on elements extracted from the earth. Lithium is often extracted from brines in dry regions, demanding vast water use which can strain communities in South America's Lithium Triangle. Cobalt, much of it from the DRC, carries severe concerns, including hazardous labor and child labor. Nickel mining can drive deforestation and water pollution if poorly managed. These facts are sobering and must be counted in the EV's footprint. The industry is not standing still. Research focuses on mitigating harms and changing chemistries. LFP batteries use little to no cobalt, directly reducing the most problematic material. Traceability and responsibility in supply chains are rising with better practices, third-party audits, and protections for workers and habitats. Every kilogram recovered is one less newly mined. These steps are not perfect but real and growing, and they matter. Section 6. The full journey. Calculating total lifetime emissions. To judge fairly, bring all the pieces together. Consider the entire life of the vehicle. The electric SUV starts with an emissions debt from its battery, but produces fewer, sometimes near zero, driving emissions. So when do savings overcome the initial cost? That moment is the break-even point. It is when the EV officially becomes the cleaner option. Break-even varies with battery size and, most importantly, your electricity grid. Suppose our EV began with 3 to 6 tons more than a gasoline SUV. On an average grid, payback can come after roughly 30 to 60,000 kilometers. For an average driver, that is about 2 to 4 years. In hydro-heavy places, it may arrive in a year, even 15 to 20,000 kilometers. Beyond break-even, savings accumulate. Over 200,000 kilometers, they dwarf the initial debt. On very dirty grids, parity can take 100,000 kilometers or more. Yet lifetime studies still favor the EV. Grids are cleaning each year, making EVs cleaner over time. An advantage gasoline can never claim. Section 7. Beyond the sticker price, uncovering hidden costs and benefits. The financial calculation goes far beyond purchase price and fuel. There are costs and there are savings. Many governments offer rebates, tax credits, and exemptions that can narrow the initial price gap. Hidden costs include a home level 2 charger since standard outlets are extremely slow. Installation can run several hundred to over $1,000. Public fast charging commands a premium for long trips, sometimes approaching fuel costs. Insurance can be higher on some models due to battery and sensor repair costs. But maintenance is typically lower. Fewer moving parts, no oil changes, no spark plugs, no exhaust, no transmission fluid. EV SUVs are heavier, increasing road wear and raising societal costs. They can also wear tires faster, adding to long-term expenses. A savvy buyer tallies purchase minus incentives, plus charger, plus running and maintenance to see the true investment. That complete picture reveals value beyond the sticker. Section 8. A balanced verdict, summarizing the trade-offs for buyers. The journey reveals no simple universal answer. They are not a perfect solution nor an environmental catastrophe in disguise. The truth is a careful trade-off. EVs shift impact from tailpipe to manufacture and electricity. For most people, in most places, the lifetime trade-off favors the climate. Primary costs, higher production footprint, driven by the battery, and reliance on improving mining practices. Benefits: lower running costs, zero tailpipe emissions for cleaner air, and quieter, smoother driving. Over a full lifespan, clean miles repay the initial debt, yielding net greenhouse gas reductions versus gasoline. Prospective buyers should assess needs, battery range, grid mix, charging access, and total cost. A right-sized battery and a clear view of incentives and running costs lead to better decisions. This holistic view gives you the true measure of the vehicle's cost. Section 9, Your Road Ahead, a call to informed action. The choice is not yes or no. It rests on knowledge and context. Debate should center on understanding compromises, not absolutes. EVs trade a higher upfront impact for long-term emissions cuts and a shift away from fossil fuels. Picture a balance, a heavy battery creation on one side and each clean kilometer adding to the other. As grids get greener, the scale tips decisively toward EVs. Know your driving habits, your local grid, and your full financial picture to estimate your own break-even. Think, compare, ask questions. Avoid clickbait promises and disasters. Use local data and calculate total cost of ownership for both options. If this clear, calm, fair exploration helped you, share it with someone deciding on an SUV. For more deep dives, subscribe to the Rachel Family channel. Don't forget to like, share, and comment. Thank you for joining us on this journey of discovery.